I want to continue with related rates, but there are things from, well, kind of before the retake that people are just confused about. So just want to make sure. What is a critical point? What makes a critical point be a critical point? Natalie.
A place where the derivative of the function is equal, the first derivative of the function is equal to either 0 or is undefined.
Okay, so given f of x's critical points are wherever the first derivative is 0 or undefined. Lots of you on the original quiz missed that or undefined. You need to list them all. Well, what makes an inflection point?
It's where the second derivative is 0 or undefined, and the sign changes from either positive to negative or negative to positive.
So an inflection point is where the second derivative is 0 or undefined, and it's got to change sign. And what is it? Can't use it in here, where the second derivative changes sign. So Josh, given this equation, how do I find the critical points?
Do you set it equal, or do you first do derivative?
Absolutely. We need to do the derivative first. So what is the derivative?
1 over, or it's 1/3 times x to the negative 2/3.
Okay, multiply by the power, so 1/3. Lower the power, 1/3 minus 1, negative 2/3. Brian, what are the places that, where is this derivative undefined?
0.
Asher, is there anywhere that this derivative is 0?
No.
No, so my only, what is this again? Lana? Critical point. That is my critical point. Definition has been achieved. The first derivative was undefined. Indy, I need to know, because critical points are called critical points because that might be where we had a maximum or where we had a minimum, or maybe it was just a wiggle. What do I need to do to test, like what we asked on the quiz? Is it a maximum, a minimum, or neither? What is it? How do you know?
Plug stuff into the derivative, so like negative 100 or positive.
Okay. So I'm going to use the number line. I'm going to name my number line f prime because that's the thing that she said, we're going to plug it in. Well, the next question is plug it into what? The derivative. I'm going to put my critical point on here, and you said plug in like negative 100. Plugging in negative 100, what does this become?
1 divided by
David here is saying it's going to be positive. Why is it positive?
Because it's to the 2/3, so it cannot be negative.
Okay. So what I've noticed is you guys also super allergic to fractional exponents. You're like, whoa, no clue, scared. And whoa, we need to be okay with that. Evaluating 1/3, and then think about it this way. What David said was we're squaring it. The top of that exponent is squared. So a negative whatever squared became positive. Third root of something positive is still positive. So over here, that was positive. Isaiah, when I plug in 8 million, what do I get?
Still positive.
Still positive. So then, Tessie, this critical point, is it a maximum, a minimum, or a neither? Okay, so, Mael,
Can you repeat what you said about the exponents?
in a minute, I'll do a separate thing just with the exponents, but, so right here, Tessie says, neither max or min at x equals 0 because,
X does not change signs.
you don't need to say that, it's already implied. So, right here, hold on Isaiah, that first derivative did not change sign, so it's not a maximum, it's not a minimum, it's a commonly known neither. Isaiah?
Two things. How do we know that there's no place where you can zero?
Okay, I have the fraction here. When is that 0? I don't know. Let's cross multiply. 1 times 1 is 1. X times 0 is 0. When does 1 equal 0? It don't. So it's never ever going to be 0.
Okay, and what about the graph that look like?
I'll show you in a second. But I want to finish. So this is analytically looking at the properties. I don't want to draw it for you yet because you're already going to know the answer. Okay, so that was our critical points. We said critical point at 0 and it was a neither. Mael, how do I find inflection points?
Inflection points is when the double prime switches signs.
Okay, all right. So inflection points are where the double derivative switches signs. So Carson, what is the double derivative of this? So, sorry, what is this guy's double derivative? So what is the derivative of that?
So it'd be just a step-by-step process would be 1 to the 2x to the negative 1/3, and 1 over 2x to the negative 1/3. So will we just bring that up and make it positive?
So power rule. The derivative of this multiplied by the power. What is the power?
Negative 1/3.
Negative 2/3.
Because it,
So multiply by the power. So 1/3 that was already here. Now multiply by the power. Lower the power. Negative 5/3. And I am just going to put it below and not write the negative anymore. So kind of yucky. Ray, where is this double derivative 0?
still at 1x is 0 because it's
So it's never 0, but you're right, it's still undefined at x equals 0. Okay, Lamb, how do I determine, like this is not an inflection point yet, because inflection points have one more stinking check. What is it?
you give the number line to the switch signs.
Where what switches signs? How am I going to
It's the
name it?
double derivative.
Okay. Name your number line with what you're testing. I erased it. So, but we already had a number line once we're checking a very different thing. So at 0, now plug in negatives, Mikhail. When I plug in like negative 1, what is negative 1 to the 5/3?
It's still negative, so it's undefined. But like it stays.
It stays negative. It's not going to be undefined. If I put in negative 1,
It's just negative.
it's negative 1. So overall, looking at the whole derivative, what is the whole thing when I plug in negative 1? Overall, is it positive or overall? It's going to be a negative here and a negative there, which makes positive. Yeah, okay. Tomorrow, now when I put in like positive 1, it's going to end up being negative. Okay, so then Iris, because of this sign change in my second derivative, what does this mean? Okay. Inflection point at x equals 0 Because, Carmen, what's the reasoning that I'd have to write on the test?
Because the second derivative, changes sign at the point x equals.
So inflection point because the second derivative changed sign. Like, those are the details and careful things you gotta do, yeah.
We also have to write that it's because it's undefined.
Okay, it is also undefined at x equals 0, and it's a good practice to say that the double derivative is undefined, but really, it can't change sign without it being 0 or undefined in there. So, all right, what does y equals x to the 1/3 look like? Well, gee, you guys all had that power functions unit in pre-cal. I know because I taught it. It looks like this. It's x cubed inversed, or flipped over the y equals x. There's a vertical tangent here. The function exists over all reals. You can do all those things. The first derivative, nah. It's not a max, not a min, vertical tangent. Second derivative, also undefined there. And look, this is concave up because it's part of the happy face. And this is concave down because it's part of the frowny face. Inflection point at x equals 0. Isaiah?
I don't understand how, the function like passes, vertical line test at a.
Because the only time this had a vertical tangent was at a single instant in time. It did not land, there wasn't another point that was on that vertical line. So we were cruising along like this, and then one split second, one coordinate only, it was vertical, and then just a tiny bit away, it went to being positive. Cool. All right. So a little late on cleaning this up, but there's some misconceptions out there that we need to fix. All right, because you do still have a test next week. Is it?
It's pushed, right?
So next week we have 4 days next week. How many of you are going to be accidentally absent? Hate you. I'll have to edit that one out. Anyone else I don't want to make. I only have 2 days where I can move the test.
Yeah, I got you.
I'm out on Thursday.
You're out on Thursday. Yeah, I wasn't planning on Thursday because
Throw it to Wednesday.
Probably
and
smaller.
record it.
Yeah, Wednesday would be Wednesday wouldn't be bad.
that is likely to happen. I don't want to promise it yet.
Alright, sounds good.
Is it gonna include what we were talking about yesterday?
Okay. Yeah. So chapter 4 is all of this stuff that you just had on the quiz. Like, how does the first derivative and the second derivative, doing the derivative was positive, and the second derivative was negative. What does it look like? If I tell you the first derivative is positive and the second derivative is negative, you should know at least some piece of what the function itself looks like. Indy?
Will there be a delta math review?
I will try and put one out there. My issue with Delta Math, I love it. It has the videos, it gives you instant feedback, and their questions aren't complicated enough. It's all on like, hey, here's this one little concept, and it makes sure you know that one concept. But the kinds of things the AP exam asks you are, hey, here's this problem. And you need to know, you need to do 5 different things to answer that one question. And Delta Math only asks those 5 different things as 5 different questions. So I will try to put something together, and they don't have everything that I need. But back to this, telling you that the first derivative is positive, the function's going to look something like that. The slope is going to go up. That's what first derivative being positive means. Ray, what does it look like when the second derivative is negative? Bottom half of that going down what?
on a graph, some negative.
It doesn't have to be. I can be concave up or down on positive y values or negative. Abby, what do you think? What does it look like?
Concave down.
It's concave down, so that's gonna look like a frowny face. Which side of this U shape is the function gonna look like if I had to have a positive slope?
The left side.
Okay, so for both of these things to be true at the same time, the function's gonna look something like that. It's gonna be any piece of that half of the U shape. So those kinds of things are partly what are gonna be on Tuesday's test. Well,
Never mind.
never mind, actually. Okay,
Checking the
Is
weather.
optimization gonna be on the test?
yeah, so,
Ready for some snow on Thursday, so I think Wednesday's definitely one.
all right.
Just my 2 cents.
So optimization and related rates, which are applications of derivatives, is the point of chapter 4. You will see those horrible, nasty problems on Tuesdays or Wednesday's test.
Did we get some more practice?
Yeah. Oh, yeah. So can you guys get out the worksheet that I gave you yesterday? We did, I think, 2.5. Yeah. All I heard was when we find the critical point. Okay, critical point of a problem really quick. Okay, what?
3x to 2/3 minus 2x.
Seems like a test.
Yeah, it sounds like a test question. That was on the quiz?
Really?
Was it?
The original one.
The original one. Oh,
It
yeah.
was negative
2x to the 2/3 minus 3x.
Well, see how you just gotta do the derivative.
What?
Where is that derivative, 0 or undefined?
I get stuck when it becomes 1/x to the 1/3 equals 2.
Okay, set it equal to 0.
No, I said equal to 2.
Did you guys?
Why do you set it equal?
Well, I said equal to 0, and then I moved the 2 to the other side.
And then, okay.
Could you solve?
Okay, hold on, guys, here's a question. Some of you got this and you were like, dang, I have no idea how to deal with this. Like, you spent a whole paragraph of pencil saying, I do not know. And this upsets me. So what is the answer? 1. How do you undo to the 1/3 power? You raise it to the 3. Okay. Y'all, this is AP calculus. You should be able to do that. Hold on, Maya. Then there was something like this.
One is not the same as
You guys were, yeah, you guys were like, oh no, hell no, can't do that.
But now I do.
Okay. And I did this exact problem at least twice in here, and I did discuss this strategy already. Like, if the exponent's freaking you out, pull it apart, x to the 1/3. And yes, with a 4-function calculator, I do still expect you to know what times itself 3 times is 8. 2. So 8 to the 1/3 is 2. And then squaring it, that's a 4. The BC Calc kids, they do it in a more difficult manner. They made it bigger, and they got 64 to the 1/3, and it's still doable, but this 64 to the 1/3 is harder to see through than 8 to the 1/3. You'll get there, but so that's an issue. Maya, specifically, what exponent issues are you complaining about?
So if the x value is in the denominator.
Good.
Something like that?
Yes.
All right. Easiest way, cross multiply. Cross multiply 2 to the x, 2x to the 1/3 equals 1. Now I've got that dreaded 1/3. How do I get the power of 1/3 gone? Cube it.
224.
So I get x equals 1/8 for that specific problem. Okay. All right. I at least want to finish the problem we started yesterday. Where we finished all of this?
Yeah, we got
We
through
finished
that.
all
We got
the
through
last
that.
one.
No, we didn't.
No,
So
we
what's called
we
that?
were on the,
Well,
we were on 4. Oh, yeah.
I think we should just hold it up to do the whole thing.
you gotta figure out how to turn on the recording. It's gonna take at
Let's
least.
not have this.
Oh, wait, actually.
So did we really finish? I didn't think we did.
We
Yeah,
got
we
one.
got
Yeah.
one.
The answer 140.
The answer is 140 units being
Yeah.
The
Feet
feet
per
per
minute.
okay. Right then. It's like I don't know in my mouth. Yes, you did. What was the equation we did the derivative of?
The secant squared.
Sort of. What was the thing we did the derivative of?
Tangent theta divided by h divided by 500.
Okay. And why, like, which of these things were variables? We said this x, the distance from the rangefinder to the start of the balloon, that thing was not moving. So the dx dt was 0. So I'm allowed to use the number here. H was moving, the angle was moving. I couldn't use the numbers. I need to do implicit differentiation with respect to time. All of these things are, how is this moving over time? The derivative of tangent, secant squared, sorry, you need to remember that. D theta dt, and then that equals 1 over 500 dh dt. D theta dt that gave me secant theta. Simon, how did we figure out what secant theta was?
We plugged in pi over 4 and then.
And I need to remember that 45, 45, 90 triangle. Secant is root 2 over 1. Root 2 squared is 2. Da 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 da. Okay. Really quick, just reading this problem. Bell still didn't ring. I have 2 minutes. People, stop shuffling papers. Reading the problem. Police cruiser is approaching a right-angled intersection from the north. Okay. Tessie is looking panicked. Oh my God, it's all right. Right-angled intersection. It's horrible. Careful, you're gonna make me bring out my Long Island accent. It's terrible.
What intersection is it?
And you have Bend to DC. There's so many
Like a
circles.
four-way intersection.
Walter, a lot of them are not.
No,
Okay.
Boston's the worst.
Anyway, lots, Walter, and that's not gonna help us. So it's coming from the north. Which way is that? So here's Mr. Cop Car. Woo! Is it going down or is it going up? Down. Okay. So this is some y value. Is dy dt positive or negative? Negative. Because it's the distance between here and there is getting smaller. So it's going to be negative. Do I know how that? Oh, the cruiser is moving at 60 miles an hour. It's getting smaller. So in these word problems, you need to be able to read the damn words and be like, going this way down. Okay, it's getting smaller. Okay, and then the Batty Bear car. Where is he going from? He's going east, which is okay, good, yeah. That way, bad guy car. And we want to know how fast the bad guy car is getting away. This is X. The cop car was 0.6 miles from the intersection when bad guy car was 0.8 miles. Is Y changing? Is X changing? They're both changing. Okay. And they're telling us something about the distance between the two cars. And they mean exactly like radar. Is that distance changing? Everything is changing. But at this snapshot in time, can I calculate, like, we're overhead and we're being thrilling Isaiah and we're watching it from the helicopter above, like, woo, look at the bad guy car's getting away. We took the snapshot. can we find that? How, Lanham, how do I find it?
I can
Pythagorean theorem. Do any of you know what 0.6 squared plus 0.8 squared is? It's gonna be 1.
Oh, yeah.
How is he
Because
doing
it's a
that?
6, 8, 10. It's a 3, 4, 5 double.
Wow.
Anyway, all right. So there's the setup.
Silly goose.
Silly goose. All right, guys.